In the previous lecture, we talked about distribution function. In this lecture, we talk about properties of the distribution function. So the first property is that this distribution function f of x is a monotonically increasing function. That is, if x is less than y, then f of x is less than f of y. So to see this is, you look at like this. So you pick up 2 points, x and y here. X is here, say y is here. So you have this and you have this. So this is f of x and this is f of y. So you see that if x is less than y, f of x is less than f of y. Now as you go towards minus infinity, f of x goes to 0. As you can see, this red graph is f of x. Now this goes to 0 as x goes to minus infinity. So x is going to minus infinity in this direction. In this direction, f of x goes to 1. So this is 1 right here. It is becoming asymptotic to 1 as x goes to plus infinity on this side. It is right continuous. This we have talked about in previous lectures. Now all probability questions about random variable x can be answered using probability distribution function. So again, recall what is this distribution function. So you have the random variable capital X here and you put small x here. This is equal to what? This is probability of this random variable capital X being less than or equal to small x. So probability that x lies between a and b, this is nothing but equal to, so what is this? This is probability that x is less than equal to b minus probability that x is less than or equal to a. So x is greater than a and less than b. So everything which is less than a, you take it out, and that will just leave you with x less than equal to b and greater than a. So probability of x less than equal to b minus probability of x less than equal to a is same as probability of x lying between a and b. So to see this on the graph, you can look at it this way. So you say you have a right here and then you have say b right here. So associated to a you have f of a right here, associated to b you have f of b right here. So this is f of b. So probability that random variable x lies between a and b, this is equal to f of b minus f of a. And notice this probability will always be positive because f of b will be more than f of a, because f of b will lie above f of a since it is a monotonically increasing function. A is less than b. So we are just using property 1 right here. What about probability of x less than c? So say c is right here. Say c is somewhere here. So we want to find the probability less than c. Then we will try to approach c from the left hand side. So we'll try to approach c from this direction and find the limit. So you find the limit here. So let us see an example where we will discuss or make use of the above properties. So we are given the distribution function, and in this distribution function we have that f of x is 0 for x less than 0. So x less than 0, it is 0. This is less than sign here, so you have a hole right here. But then between 0 and 1 it is x by 2. So we draw the graph of x by 2. So you can think of it as y equals to x by 2, where y is f of x. So this is the graph of x by 2. Then at 1 there is a hole. So between 1 and 2, x is 7 by 12. So 7 by 12 is somewhere here. Between 1 and 2, this is 7 by 12. you have hole here. Then between 2 and 3 it is 11 by 12. So again it jumps, becomes 11 by 12. Say it is somewhere here. Then greater than 3 it is 1. So then it is given to us, it is 1. So obviously this is a distribution function. Now as we go towards plus infinity it will stay at 1. As we go towards minus infinity it stays at 0. So let us compute things from it. So probability that the random variable x is less than 3, talking about this random variable capital X, this is less than 3. So this probability is 11 by 12. You just see from here. So the small x is less than 3, that probability is 11 by 12. So you just copy right here. Probability that x lies between 2 and 4. So now we use this formula. Instead of a you have 2, instead of b you have 4. So this is equal to f of 4 minus f of 2. So what is f of 4? So at 4, f of 4 is 1. So at 2, f of 2 is, so there is a hole here, so you can't take this value. You have to jump up here. So this is 11 by 12. Let me write this. This is 11 by 12. So you write 11 by 12 here. 1 minus 11 by 12, you get 1 by 12. So the probability that the random variable takes value between 2 and 4 is 1 by 12. So what is probability that x is exactly equal to 1? This is probability of x is less than equal to 1 minus probability of x is less than 1. So this will give you exactly x equals to 1. So probability x is less than equal to 1. So instead of x you are putting in 1. So this is nothing but f of 1. So what is f of 1? So f of 1 is right here. So f of 1, there is a hole here. You have to jump up right here. So f of 1 is right here, which is 7 by 12. So this is f of 1. So because there is a hole here, we have to take this value. So this is 7 by 12, f of 1. Probability of x less than 1. So instead of c you put 1. This is f of, instead of c you have 1. 1 minus h. H goes to 0 from the positive side. So f of 1 minus h. So that basically means h goes to 0 from the positive side. That is, we approach from the left side, as we just discussed a few minutes ago. So we approach 1 from the left side. So if I approach 1 from this side, I reach half. I do not reach 7 by 12. I reach exactly half. Half or 6 by 12. So you can see it right here. F of x you put, so you have f of x is equal to x by 2. So f of 1 minus h is 1 minus h by 2. And when you take limit of h goes to 0, this 1 minus h by 2 becomes half. The limit h goes to 0 of this expression becomes half. And that is what we are taking half right here. Limit h goes to 0 from the positive side, that is, we are going from the left side. This gives you half. So 7 by 12 minus 1 by 2 gives you 1 by 12. Probability that x is less than equal to 1 by 4. Again, this is nothing but f of 1 by 4. We are again using this formula. Instead of small x, we are plugging in 1 by 4. So this is equal to, we had x by 2. So instead of x, you have 1 by 4, 1 by 4 by 2, which is 1 by 8. Probability that x is greater than 1 by 4. So that is nothing but complement of the set where x is less than or equal to 1 by 4. So if x is not equal to or less than 1 by 4, it has to be greater than 1 by 4. So this will be 1 minus probability of x is less than equal to 1 by 4, which is 1 minus 1 by 8, which gives you 7 by 8.